What up, guys? Welcome back. As you can tell, we have Windows 11, so I got a new computer. Got this crazy good deal, $750, and I wanted to totally upgrade my PC. So, yeah, I got this crazy good deal. I'm pretty happy with it. So, got a new computer. Probably gonna boot Linux on this, do boot Linux and Windows on this sometime soon, but just trying to get settled in with it and kind of get everything else going again. So. Today will probably be a little bit shorter of a video. Probably just gonna do maybe 2 problems. So, I've been out all day doing this. Oh my gosh, dude! And I have to get dark mode, bro. Or dark mode Chrome, dude. I think I have to install this. Oh my god! How do I do this? At the bottom right, new page, customize Chrome. You have to go to settings or something. Appearance, dude. How do I make this dark mode, dude? Dark. I think I have to get the Chrome extension, bro. Is this it, bro? I don't know, dude. Please, in blind, bro. Oh, bro, Leetcode looks so bad. Jeez, bro. Leetcode dark mode. How do we do this? I did this last time. I just don't remember how. Is it this, bro? I don't know. No, dude. Jeez, man. Oh my gosh, dude. What is going on right now? Get me out of this, bro. Okay, that's better. Okay. Yeah, so gonna look at our powerful study program. Actually no, let's just go straight to Leetcode 75. Probably just jump in and do a couple problems here. Let's do a DFS. Then we can do a BFS. I mean, we've already done a BFS. I remember doing both these ones. We can do the right side one. I mean, I know I submitted this. Yeah, I did this the other day. I remember it. It's C++, bro. Jeez. Okay. So here we're just going to read a binary tree. Imagine yourself standing on the right side of it. Return the values of the nodes you can see ordered from top to bottom. Okay. So to solve this problem here, we want to import a queue here from collections. Import DQ, right? And we want to loop through here. We want to initialize a queue. So queue is equal to DQ. And we want to pass in probably our root, right? And we want to do while queue. We want to call our length. Length is equal to the length of queue. Then we want to loop through our for loop, right? So we want to do for I in range length queue. Sorry, we can put length here, I guess, in a way. Right? We want to check, well, what do we want to check? Oh, we need some sort of res array, right? That is equal to this. We want to do that. And then we want to do, well, if I is equal to the length of queue. equal to the length. We want to do res.append. Wait, rip. We want to pop that node, so node is equal to q.popleft, right? Well, if res.append node.val, then we're going to do, well, if node.left, q.append node.left, if node.right, q.append node.right, and then I think we want to return our q, right? See how this looks so far. Object is not iterable. Do I really have to do this, bro? Like, oh my god, bro. So we want to return our res. That's what we want to return. Non-type object has no attribute left. If not, root return just an empty string. See now. Okay. We're actually not appending any values, so it has to be if length -1. There we go. That's a pretty simple problem. That can be our BFS problem for the day. Let's take a look at path sum 3. Oh my gosh, dude. Given the root of a binary tree and an integer target sum, return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards, traveling only from the parent nodes to child nodes. So 8 is shown. This is definitely an interesting problem. How we go about this? Not really sure. Sorry about that. Trying to think here. See optimal way to pass this drone. Oh, bro. Man, I really don't like this. We need a dark mode Chrome extension, bro. Oh my god, dude, what is going on here? Oh jeez, man. This is what I mean, bro. Setting everything to dark mode, dude, is just insane, bro. Dude, how do I... Bro, how do I... Bro, what is this, bro? What is this? Okay, alright. I think that's good. Okay. Okay, let's go back to this one and resubmit this. Just want to make sure this is. I forgot I didn't have this. Got another new computer. I think I gotta sign into Leethub. New computer, bro. Oh man, it resets it, bro. Whatever, dude. There we go. This should be pushing now. Okay. Alright, sweet. Okay, back to this problem. I think somehow we probably just gotta go from the node and go all the way down. I'm going to work at McDonald's. Fries in the back. So I think, can we do recursion? I don't know. I'm gonna need some sort of hint, bro. I'm not sure how to approach this problem. Oh god, dude. Dude, dark mode for everything, bro. Okay. 437. Okay, let's do 437, part sum, I. Prefix sum approach to efficiently count the paths that sum to the target. Instead of checking all possible subarrays with a nested loop, use a hash map to store cumulative sums and look for the difference between the current sum and the target sum. For FDFS. Node. We're gonna need some sort of res integer to return the amount, right? So we'd probably return the res. let's, we can return some sort of like turn count, right? Here we can oh god, man. Dude, it cannot be this, bro. Like, there must be some sort of dark mode in Chrome. There has to be, like. Bro, jeez, man. Yeah, settings. Jeez, man, that hurts my eyes. I gotta figure that out. Collections input default dick. Your default dick, right? I think it's like that. Major in there. Return node. We got a my dick 0 is equal to 1. We initialize first element root for prefix sum, right? Probably got to keep track of the prefix sum here. Oh, it starts at 0. I'm actually not sure. So.
Welcome to August Leetcode Challenge. Today's problem is path sum 3. We have a binary tree which contains integer values. Find the number of paths.
Bro, this is driving me insane, bro. Oh my god, dude. Like, seriously. It's driving me insane, bro.
That sum to a given value. Now, a path does not need to start from the root, but it needs to go downwards. We can consider 5 to 3 here a path, 5 to 1 a path, -3 to 11 a path, so on and so forth. And we just want to find the total number of paths that equal that sum. So the most straightforward approach would be to do a depth first search at each node. So say that we start at the root and check to see, while we're traversing down in a depth first search, if any of these paths equal 8. If they do, we increment our total by 1. And we can check each one for every single path. But the problem is the paths don't need to start from the root, right? So we'd have to also check for this node going all the way down, this node going all the way down, and so on and so forth. So the time complexity starts to become exponential. But regardless, let's go ahead and try to implement that solution. The way that I suppose I could do it is to have 2 methods. One for, I'm going to call helper. And this is going to be the thing that actually counts up the path sum. I'm going to initialize a self variable, kind of like a global variable here. And we'll make that equal total. So for now, I'm going to pass on the helper method. This is going to be the main part where we just do a normal depth first search, right? So if you remember, all that is if not node, return. Otherwise, we go left and we go right. And finally, that'd be it. But here we want to call our helper method. And what do we want to pass? Well, basically, we want to pass the current node and also the current value. And that way, what we're going to do here in our helper is going to do a depth first search again. And we'll say same thing, if not node, return. But we are going to call the left as well as add to this. Actually, we don't need to do that, do we? I suppose we will pass in the current. And we'll pass in the current here as well. And finally, we'll say, hey, if cur plus the current node's value equals sum, then we'll increment our total by 1. And I'm trying to think if I need to add to...
Man, this is hurting my eyes, bro.
I
so
suppose
bad.
I do. I have to add to this current node.value. And that should be it. All I have to do now is call this depth first search with the root and make the... Oh, we don't need to do that. We just need to pass in method. Well, I suppose we need to pass it in here too then. Well, I think we can just pass 0 here. I think that's fine. And finally, return the self.total. So let's see if this works. I may have missed something here. Looks like that's working. Let's go and submit that. And accepted. All right, so that's great. It works, but this isn't very good. This is obviously doing lots of repeats. Is there a way that we could do this in O of n time? Like we're passing through every single node. Can we somehow take some value and kind of keep track of everything that we've been through so far rather than just doing it over again? So to do that, that's a little trickier, right? We have to pass some sort of object. So how about we have a dictionary? We'll have a lookup table that's going to store kind of like toSum, where we'll store the amounts that we've gathered so far and count the number of paths that we can bring over. And if we find that, yes, at this node, we've able to get this sum, subtracting everything from before, then we will add the total number to our total as well. Okay, so that's much trickier, but we could do it. We can do that. And we'll initialize a lookup. We'll make this a default dict with integer values being the default value. And we no longer need this helper method. We could do this all in one depth first search. But to do that, we will have to pass in the node as well as, let's call it root sum. And we need to pass this along to get this right. So first, let's go ahead and just delete that. We don't need that. It'll still be, if not node, return. And now what are we going to do? Okay. So we take our root sum and we're going to add to it our current node's value. Now we want to add to our self total if anything we've found inside of our lookup table, I believe. So we look at our lookup and get our root sum, and we'll add to our total, assuming that something is already there. So what else? Now we have to total lookup. I suppose we have to update our dictionary, and what we're going to do is add root sum as well as sum, because we have to keep in mind this is going to be as we add up moving forward. If we want to figure out if we could subtract it, it's actually adding, right? So that is going to equal +1, and we'll backtrack here. once we're out of this part, we will have to subtract the same thing. So the only tricky part here is trying to figure out what I need to pass. I believe it's root sum. And root sum starts with 0. So let's see. I don't think I missed anything, but let's make sure that works. I think it does. Let's go ahead and submit that. Dang it. Okay. So I messed something up here. Root sum. Value. Why didn't it?
Okay, so here we have a normal DFS, if not node. We want to loop through. See an empty node, right? We want to increase node of, prefix sum plus or equal to node of val. Check how many times.
Output 1. It might be because I haven't initialized my lookup at sum to equal 1. Let's see if that's why. So let's take this and just make sure this works. Okay, so I believe that's right. Yeah, so I had to initialize, of course, in my lookup, start with 1. Otherwise, it's going to start at 0, so it's not going to add up the ones whether that do equal that sum. So here we go. This is the O of n solution. Very tricky, but it's, you know, if you have those concepts from like toSum before and lookup, and you're able to do this step first search, hopefully you can kind of get it. And
I just don't really understand this this lookup here. I know we do this in toSum, the O of n solution in toSum, but I just didn't really understand that properly, I don't think. So dick prefix dot left prefix sum count plus or equal to DFS no dot right prefix sum. Then we backtrack prefix sum minus equal to 1. Yeah, return count. I just don't really know. Hmm. I don't really understand, man. I'm trying to learn these test cases, but -18 -8, dude. I don't get that. All right, we're gonna run this code. Name node not defined. It's meant to be root. I'm gonna end it here because it's late. But take a look at this problem again tomorrow. Jeez, man, what is going on here? Oh, there we go. Okay. Yeah, we're gonna leave this code. I'm not gonna submit it because I don't feel comfortable submitting it. Maybe we'll take a look at it again tomorrow. But yeah, just a short video. I appreciate you guys watching. I will see you tomorrow.